Hey everyone, welcome back, and today let's solve Leetcode problem 1399 titled Count Largest Group. So we're given an integer n, and each number from 1 to n is grouped according to the sum of its digits. We want to return the number of groups that have the largest size. So in example 1, we have our input integer n to be equal to 13, and in this case we have an output of 4. First of all, why is the output even 4, and what does that signify? Well, 4 is going to be the number of groups that have the largest size. And again, numbers or integers in the range from 1 to n are grouped together or are in the same group if they have equal digit sums. And how do we know if they have equal digit sums? Well, we have to kind of compute them themselves and compare and group them accordingly, right? So again, there's going to be 9 groups in total. Basically, 9 unique groups or 9 unique digit sums in total across all the integers in the range from 1 to n, right? And so those groups are going to be 1, 10. Notice how both 1 and 10 are in the range of 1 to 13 inclusive, and they both have an equivalent digit sum of 1. Because 1 plus 0, or just 1 by itself is of course 1, and 1 plus 0 is also 1. The same thing applies with 2 and 11. They're both in that range from 1 to 13. They both have an equal digit sum of 2. The same thing applies with 3 and 12, 4 and 13. And as you can see, 5, 6, 7, and 8 are all alone because there are no other numbers in the range from 1 to 13 that have an equal digit sum as these guys. Now, notice how we don't care about these groups because, of course, they're just groups of individual numbers. We only care about the groups that have the largest size, not the largest digit sum, but rather the largest size in the number of elements that have that digit sum, or number of integers that have that digit sum. And here, all of these 4 groups have a length of 2, meaning there is 2 or 1 pair or 2 elements or integers that have an equal digit sum in these 4 groups. And since these 4 groups are by length the largest 4 groups, these are the only 4 groups we care about, and that's why we have an output of 4. There's 4 groups that have that largest size of 2, or all the elements in the group, of course, are in the range from 1 to n and have an equal digit sum. In example 2, we have our input integer n to be 2. There's really only 2 groups, 1 and 2 by themselves, and they're each going to have a size of 1, which in this case is actually the maximum group size. Hence, we have exactly 2 groups of that maximum group size, making that our output of 2. So for the constraints here, we see that n is actually going to be between 1 and 10 to the 4th power. And that's actually rather expected. At the end of the day, this is an easy problem. We shouldn't expect too large of input constraints by any means. Now, you may be looking, for some key patterns to really look for when trying to solve this problem in the most efficient way possible when computing the number of different groups with that largest size. Now, you may notice some patterns, like, okay, if we take 14, for example, 14 is going to have the same digit sum as 40, which is going to have the same digit sum as 41. Notice how these two guys are palindromes, and 40 is just basically, not 40, but 50. And 50 is just basically 5 as a digit sum and an extra 0 to tag on. But what if 41 or 50 isn't in the range from 1 to n? Or, what if maybe 41 and 14 are, but 50 isn't, right? You have to start thinking of these different kind of possibilities, and these kind of branch into a lot of different conditionals to check, which make this problem unnecessarily difficult. And so let's go back to the nature of this problem. It's an easy problem. We have rather, simple input constraints of 1 and 10 to the 4th, telling us that, okay, we can definitely have a linear or big O of n solution and still be completely fine. And that brings us to, how do we really solve this problem? Well, if we can't really formulate any patterns officially and keep checking whether all the integers that we check to form that pattern are between 1 and n, because again, that pattern kind of is every single number is the same digit sum with its palindrome. Really, all we can do, considering that big O of n works, a linear solution is more than efficient, we can really just iterate over all the possible integers from 1 to n and group them together with other numbers that in that range that have equivalent digit sums. And we want to find the maximum size among the groups because, of course, those are the only groups that we actually care about, and count how many groups actually have that length of the maximum size, which is eventually going to be our output. So, I have been hinting at this, so far in the video. We want to group elements with other elements according to or mapping to their digit sum. And what is a very, very nice data structure to do that? Well, you guessed it, it's the dictionary. Now, more specifically, we want to actually use the default dictionary because we're going to assume that all elements have basically a default digit sum of just say 0, and we'll just assume that all the elements that we're iterating over in the range will eventually find, or we will eventually find a digit sum. And so we're going to use a default dictionary so we don't have to consider any keys or any digit sums that we haven't found before that aren't actually keys in the dictionary at that moment. That's the whole point of a default dictionary. We have default key value pairs and keys for keys that even aren't even in the mapping or hash map itself. So I'm going to get count, and I'm going to call it count, and I'm going to initialize it to be a default dictionary. And for my parameter here, I'm basically just going to pass in the default parameter or data type of all my keys, which in this case, of course, are going to be integers because, of course, we're mapping integers in that range to integer digit sums, and so that's why our data type is an integer. Now let's actually begin iterating over all the possible values from 1 to n and mapping them with their corresponding digit sums after we actually calculate their digit sums. So for every value I or integer I in the range from 1 to n. But in this case, for Python, for loops actually go up until n minus 1 for the second parameter. And so to account for that offset or that exclusive value, to include n in this iteration, will go up until n plus 1 exclusive or n inclusive, right? So for I in the range of all of these values, let's actually compute the digit sum of the current integer n. Now, what is a very neat way, I want to say somewhat complex Pythonic way to do this as a one-liner, how to actually calculate the digit sum? Well, we can't iterate over elements or digits in an integer, but we can in a string. And so we can kind of convert the current integer to be a string, iterate over the string, and calculate the individual digit integers and map them or sum them all together. And so it's going to basically be an entire sum of the digits of all the integers in the string of this current integer I, right? So it's going to be basically every integer d for every single integer d or digit d in the string of I. We're basically just converting the integer I to be a string, iterating over all the digits in that string, converting those digits to be integers, and actually summing up all the integer digits to get the actual full or total digit sum for across all the digits for this current integer I. And now, once we've actually got this digit sum, great, we've seen one more occurrence with the current value or integer I that has this digit sum in this range, and so we want to increment the count of this digit sum that we just computed by 1. And the best part is, we don't even have to check if this digit sum is even in the default dictionary because it is a default dictionary and it will already have a default value of 0. We're just incrementing its frequency by 1 because we just found another value I in this iteration that actually does have a digit sum of this value, and so we're going to increment its frequency by 1. Now, once this for loop is actually done executing, all values in the range from 1 to n would be mapped to their corresponding digit sum, and now we have to actually find the largest kind of length or the largest number of elements that have or are in the same group. And to do that, we'll just call it we'll just call it anyways, we'll just call it max size because it really just indicates the max size or most number of elements in a group, and it's going to be the maximum of the values in count, or count.values in Python. Now, what count.values basically does, it basically gets all the key value pairs or mappings in a dictionary hash map and gets the maximum value across them. And in this case, the key value pairs are nothing but the actual number of elements or frequency of digit sums that we computed across all the elements. And so we're going to get the maximum of the frequencies of all the different digit sums that we calculated, because the frequency of the digit sums are nothing but the number of elements that have that digit sum. And so the maximum of that would basically be the maximum length or the maximum group of elements that have an equal digit sum. And once we actually compute that max size, we just want to return the number of groups that have that max size. And basically it's going to be another sum, and so I'm going to return the basic total sum for every single value v in count.value. So I'm basically using v as my iterator and iterating over all the values or frequency of all the digit sums, our key value pairs in the dictionary. And if v is equal to the max size, meaning if the current v group actually does have the max size elements that we computed on line 7, meaning it is one of the largest groups, well, then we want to add 1 to our sum because we found one more valid or largest size group. And so we're going to sum all ones for all the values or groups in the count that have that max size and sum them all up for one, accounting 1 for each one, and return that sum. So unless I made any syntax 0, 0, this should be accepted and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So on a high level, again, what are we really doing here? Effectively, we're just iterating or initializing this default dictionary. We're iterating through all the values in 1 through n. We're basically counting or grouping or mapping how many numbers fall into each digit sum group after computing their digit sum in each iteration, finding the maximum size among all the groups, and counting how many groups or summing how many groups have that maximum size throughout all the groups that are stored in the dictionary from all the integers that we actually mapped in the range from 1 to n. So that brings us to the complexities here. For the runtime complexity, we kind of touched up on this. It really is just linear, right? We're iterating through all the elements from 1 to n. We're going through each element exactly once, and so it's going to have a big O of n, or linear linear runtime complexity. And for the memory complexity, it's also linear, big O of n. Why? Because, well, we have this auxiliary memory or extra data structure of the count hash map. It is going to store, worst case, n different groups, assuming that all the values in the range from 1 to n all have different or unique digit sums, and so we're going to have 9 different key value pairs or 9 different keys, but that is really worst case. But on average, it's going to be about big O of n or linear for both the runtime complexity and memory or space complexity. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in the next video. Bye bye.